Okay, so today what we need to talk about again are rational functions, which is basically fractions. But when we talk about fractions, we're going to have x's in the denominator, which causes some problems because if you have x's in the denominator, then you have the possibility of dividing by 0. If you divide by 0, that's a really bad thing, right? So, example 1. So first of all, it's not a bad idea to just take a look at it and say, okay, well, gosh, if I want to graph it first and see what's going on, if you do put it in your calculator, make sure you put parentheses, right, and parentheses, because you need the entire top divided by the entire bottom. So if I go y equals, cleared out, right, if I start with my parentheses, x squared plus 2x minus 3, right, divided by parentheses, x squared minus 1x, subtract 12, right? Got it? Okay. So let's see what it looks like. I have a feeling we're going to have a couple of bad things happening because we certainly have the possibility of dividing by 0, right? So if I go and push graph, okay, it looks like an asymptote, doesn't it? Okay. So, and it looks like we might have a horizontal asymptote also, right? But they don't draw them in because the asymptotes are not part of the graph. They're invisible boundary lines. Does that make sense? So the calculator's not going to show it. Every now and then it'll show it, but that's just because the calculator gets confused for a second, right? So if that's what it looks like, let's see if we can come up with some reasoning. So before I do anything, let's factor. Let's take f of x and let's factor, okay? So I'm going to have an x plus 3 over an x minus 1, okay, for the denominator, or for the numerator. And for the denominator, I'm going to have a x minus 4 and an x plus 3, okay? Now, right off the bat, the first thing we need to consider is problem spots. So problem spots have to do with dividing by 0. Divide by 0, frowny face. Okay, you okay with frowny face? Sad, sad, sad. Cookie Monster sad. He's getting his asymptote kicked. Poor Cookie Monster. So here's what we know. X cannot equal 4 and x cannot equal negative 3, right? Everybody good on that? So if we go back and look at our calculator, right? Yeah, okay, seems like we should have an asymptote at 4. That concurs to my picture, doesn't it? So I'm going to go ahead and draw in at 4. So I'm going to go 1, 2, 3, 4, right? I'm going to draw in a asymptote, right? So it's a dashed line because it's not really part of the graph. It's only a boundary line. It's a line to infinity is what it is. It's a line to infinity. It's going to show that the graph is heading off. So if I take a look at my calculator again, you can see that this graph is heading off to infinity, but bound by that asymptote, okay? So now there's another problem that's at negative 3. But what we noticed is that we could get rid of the problem, right? So if we can remove the problem, I know there has to be a hole at x equals 3, okay? So that's got to be a hole. Now, if it's a hole at x equals 3, negative 3, then we can find its y value. To find the y value, let's take our canceled function, our f of x equals now x minus 1 over x minus 4. Because if I cancel out my problem, my x plus 3, I get rid of it, I can now plug in the negative 3, right? I can plug in the negative 3 now. So if I plug in the negative 3, I can go f of negative 3 would be a negative 3 minus 1 over a negative 3 minus 4, right? Which makes a negative 4/7 or a 4/7. You okay with that? So the value of my hole. The hole has a coordinate. If it's a hole, my hole has a coordinate at negative 3 and then 4/7. Okay, so let me go ahead and put that in. So at negative 3, 1, 2, 3, and 4/7 to pull a hole. Okay. So far, so good? All right, in fact, it might be interesting just to try a trace button and go to negative 3, and sure enough, if I take a look at it, you know, negative 3 has no y value, right? It's gone. It's a hole. You fell through, okay? So then, if we keep going with this, we should have some kind of a horizontal asymptote. So let's go to infinity. Let's take our original horizontal asymptote. And let's go infinity squared plus 2 times infinity minus 3 over infinity squared minus 1 times infinity minus 12. And we're just going to gobble things up. In calculus, Mr. Massey is going to show you mathematically why this works. I can show you too, but this is just much easier, right? So gobble gobble, it's gone. Gobble gobble, gobble gobble gobble, it's gone. So we're left with infinity squared over infinity squared, which should be 1, right? You guys agree with that? So my horizontal asymptote is at y equals 1. Okay, so I'm going to put that in my graph also. Yes? The 1?
Just the whole thing.
You mean, oh, I plugged infinity into the original.
Okay.
I just plugged infinity into the original, okay?
If you subtract infinity from infinity, which one solves that?
That's a really good question. Yeah, it depends on the degree of the infinity. If it's infinity minus infinity, it's just 0, right? If it's 2 infinity minus infinity, it's still 0. I know. You gotta wait till, when we get into calculus, we'll talk more about it, okay? Okay, so now, James, you ready? So let's draw it in. We know at least what the picture looks like, so it should look like this, right? And like this. Now, what if we need X and Y intercepts? Because it really does have an X and Y intercept, right? So let's do our X intercepts. So to get our X intercept, let's let Y equal 0, right? Okay, let Y equal 0. So if I go back to my factored form, listen to what I say. 0 on the top is 0. 0 on the top is 0. So if I go back to the original factored 1, the value of 1 would make it 0, wouldn't it? So we're going to have, if x equals 1, and so I'm way off on my graph. It should be there, right? See how far our graph, my x-intercept should be here. Let me get my white out and redraw this a little bit better. All right. So my x-intercept is right there. Now what about my y-intercept? So my y-intercept is when you let x equal 0, okay? So if I go back to the original, if I let y equal 0, if I let x equal 0, you just get negative 3 over negative 12, wouldn't you? Can you see that? If that's 0, that's 0. If that's 0, that's 0. We just get negative 3 over 12, which is a 1/4, okay? So right at 1/4, and that makes sense. So here we go. I've got an x-intercept at 1, 0. I have a y-intercept at 0, 1/4. It's getting hard, isn't it? Love, it's a beautiful thing, isn't it? It's a beautiful thing. Sideways, thumbs up. Okay. All right. Ready to turn the page? Okay. All right. Slant asymptote. All right. Okay, now to find the slant asymptote, we are going to do synthetic division. Okay? To find a slant asymptote, we're going to do synthetic division, all right? So whenever, let me go back to the reading, okay? Boys watching? So, when you find a slant asymptote, that's where the numerator is 1 degree more than the denominator, okay? Slant asymptote, the numerator is 1 more degree than the denominator. That's what I have. I've got an x squared, and I got an x to the 1, okay? We will have a slant, for sure. We will have a slant asymptote, okay? So if you have a slant asymptote, you will not have a horizontal one. If you have a slant, you will not have a horizontal. You can't have no horizontal. If it's going like this, it's tipped. It's not flat, okay? So before we do anything, let's take a look at what it looks like. Okay. I like Lane's suggestion. Let's take a look at it first, see what's going on, right? So y equals, clear that, parentheses, right? Let's go x squared minus 4x, subtract 5, divided by parentheses, x, subtract 3, right? And graph it, okay? Okay. So it looks to me as if as it goes off to infinity, it might be approaching a line that goes like this. Maybe, right? It might even have a vertical asymptote here somewhere. Right? It might. Maybe. But we can find that all out by taking a look at the function. Okay, so let's look at the function. What do we know about the function? First of all, x cannot equal 3. Do you agree with that? X cannot equal 3. Let's try and factor the top to see if it's removable. So I'm going to try and factor. So if I factor it, I'm going to have a x minus 5. I'm going to have an x plus 1 over an x minus 3. Okay, everybody see that? I just factored. Okay. Okay, I factored it. X minus 5, x plus 1 over x minus 3. Cannot get rid of the problem. Cannot remove it, can I? So it's not a hole. It's a vertical asymptote. So at x equals 3, we have a vertical asymptote. Okay, that's kind of what I thought. Go back to looking at that, right? I kind of thought there was one there. Yep, sure enough there is. Now, let's see. There is a slant asymptote. In order to find the slant asymptote, we're going to do synthetic division. So I'm going to go and take my original, bring it down here. I'll go 3 into 1, negative 4, negative 5, right? Step 1, bring down the 1, multiply, I get 3, add, I get negative 1, multiply, I get negative 3, add, and I get negative 8, okay? How am I doing? So there's my synthetic division. If you want to find your slant asymptote, you need to get a different equation. So what I get is a y equals a 1x minus 1 plus a negative 8 over x minus 3, okay? There's your slant asymptote. You ignore your remainder because as you head to infinity, this becomes 0, okay? As you head to infinity, this becomes 0, okay? That's your slant asymptote, okay? Now, let's take a look at zeros. Let's see if we can find some zeros. So, if I want X-Intercepts, let y equal 0. Alright, I can do that. So I get 0 equals my x minus 5 over my x plus 1 over x minus 3. Okay, now, to make this easy, ready? 0 on the top is 0. 0 on the top is 0. Okay? So at x equals 5, so at x equals 5 and x equals negative 1, those are x-intercepts. So we'll have a point at 5, 0, and a point at negative 1, 0. Hey, let me check my picture to make sure I'm doing everything right, okay? What do you know? That looks like negative 1, doesn't it? And 1, 2, 3, 4, 5. There's 5. Those are my zeros, right? So I could have got it from the calculator, but what the heck? The math works, right? The math does work, okay? Now, what about y-intercepts, okay? Y-intercepts, let x equal 0. Okay, so if x is 0, we would have, okay, real quickly, to have a 0 squared minus 4 times 0 minus 5 over 0 minus 3, but that's just going to give you 5 thirds, okay? Do you agree with 5 thirds? Do you agree with 5 thirds?
Yes.
Negative 5 over negative 3, negative 5 over 3, or 5 thirds, okay? So that means we're going to have a y-intercept at 0, 5 thirds. Okay, so check it out. Let's see if my picture makes sense. So there it is. You see where my pen is? Right there. That looks like 5 thirds, doesn't it? Yeah. Okay, so now let's graph it. So we're going to graph this darn thing. Squeeze it in down here. I'm running out of room, but when I graph these, I graph the asymptotes first. I do. I graph the asymptotes first. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4, 5. 1, 2, 3, 4, 5. Okay. So vertical asymptote at 3. Right? Now how does the slant asymptote work? Well, just like we graph this line. Start at -1, go up 1 over 1, up 1 over 1, up 1 over 1, right? Start at -1, up 1 over 1, up 1 over 1. Okay. Let's graph a couple of points I know. 5, 0. Right? -1, 0. Right? Am I going too fast? So I'm just going to graph a couple of points I know. I know I've got a point at 5, 0 as an x-intercept. -1, 0 as the other x-intercept. Okay? And then I've got a y-intercept at 0 and 5/3, which is like 1 2/3 is about there. Okay? So then my picture really ought to take shape. If I take what I have here and just graph it in, I ought to be able to just go, right, and there. Homework's upside down. 308, 29, 35, 63, 76, and 82. Okay. Yeah.